Okay, welcome to the first lecture of Internet of Things, that is CITS5506. I am Dr. Atif Mansoor and will be teaching this semester the unit Internet of Things. So first thing that what is Internet of Things? I am going to introduce the term Internet of Things, but before I introduce what our Internet of Things is, I would like to know, what do you understand? What is your opinion that what is Internet of Things? So the word Internet of Things consists of three words, two major ones. One is the Internet and second is the things. So one can say that it is the things which are connected to the Internet. And then the next question is, what is the significance? Why you should take this unit, and what are the related prospects for you as a student of taking this unit of Internet of Things? So before I start, I show you one of the videos which will introduce this topic of Internet of Things to the students.
The Internet of Things is changing much about the world we live in, from the way we drive to how we make purchases, and even how we get energy for our homes. Sophisticated sensors and chips are embedded in the physical things that surround us, each transmitting valuable data that lets us better understand how these things work and work together. But how exactly do all these devices share such large quantities of data, and how do we put that information to work? Whether we're improving the production of a factory, giving city residents real-time updates on where to park, or monitoring our personal health, it's the common Internet of Things platform that brings this diverse information together and provides the common language for the devices and apps to communicate with each other. The process starts with the devices themselves, which securely communicate with an Internet of Things platform. This platform integrates the data from many devices and applies analytics to share the most valuable data with applications that address industry-specific needs. Let's start with a simple example, a car. After taking a long road trip, Rebecca notices that her check engine light has come on. She knows that she needs to have her car looked at by a mechanic, but is not sure whether it's something minor or something that needs immediate attention. As it turns out, the sensor that triggered Rebecca's check engine light monitors the pressure in her brake line. This sensor is one of many monitoring processes throughout the car, which are constantly communicating with each other. A component in the car called the diagnostic bus gathers the data from all these sensors, then passes it to a gateway in the car. The gateway integrates and sorts the data from the sensors. This way, only the most relevant diagnostic information will be transmitted to the manufacturer's platform. But before sending this organized data, the car's gateway and platform must first register with each other and confirm a secure communication. The platform is constantly gathering and storing thousands of bits of information from Rebecca's car and hundreds of thousands of cars like hers, building an historical record in a secure database. The manufacturer has added rules and logic to the platform. So when Rebecca's car sends a signal that her brake fluid has dropped below a recommended level, the platform triggers an alert in her car. The manufacturer also uses the platform to create and manage applications that solve specific issues. In this case, the manufacturer can deploy an application on the platform called the Asset Management System. This application oversees all of their customers' cars on the road, as well as all the parts in their warehouses. It uses the data from Rebecca's car to offer her a potential appointment time to service her car, directions to the nearest certified dealer, and a coupon for the service. What's more, the app will ensure that Rebecca's brakes are covered under her warranty, that the correct replacement part is ordered, and then sent to the dealership so it is ready when she arrives. But the manufacturer's analysis does not stop there. They have also deployed a continuous engineering application that tracks not only Rebecca's car, but hundreds of thousands of others, looking for ways to improve the design and manufacturing process of the car itself. If the same problem in her brake line crops up in a critical number of other cars, the manufacturer uses applications custom-built for the automobile industry to pinpoint the exact problem. They can see if these cars were made at the same factory, used the same parts, or came off the assembly line on the same day. So what do all these pieces add up to? Streamlined inventory management for the dealer, a better, safer car from the manufacturer. And for Rebecca, it means she can be back on the road faster and get to where she's going safely. All thanks to the Internet of Things.
Okay, so there are two major components of this course. One is the theoretical component and one is the practical component. In the theoretical component, we will have discussion on the technology. There will be various presentations by the experts of the area. We will go through some of the research papers and articles. So there would be naturally the reading assignments. Then there are student essays. So you have to choose one of the area related to Internet of Things and research the topic and write an essay. And naturally, this essay would be also presented. So you have to give a presentation. In the practical component of the course, you would be taught to have an IoT-based application, the physical computing using Raspberry Pis, Arduino board, and we would also have a component of LoRa transceivers. So you would be connecting your LoRa transceiver with a gateway, that's the UWA gateway. So we have at the moment a UWA gateway running of LoRa. So you would be provided with the hardware through which you would get connected to that gateway. Now, so there is a term project, which is a group of 2 students or the 3 students have to perform. And at the end of the course, you will present your work. Coming to the grading aspect of the course, there are 2 quizzes, 15% of each. That means it would give you a 30% weightage. One is a written essay, that is the IEEE style 3 to 4 pages double column essay. It will have, it's an individual work, so it would have a 25% weightage. That is 10% for the presentation and 15% for the written essay. We have a group project, so 25% for the that is the presentation of 10 to 12 minutes. So you would be rated on the basis of your idea, comparison with the existing techniques and the approach which you have followed, and 20% is for the prototype. So you would demonstrate that physical thing to the class after the presentation. So coming to the essay, it's an individual essay. In extreme cases, we may consider a group of 2, but it has predominantly, it's a single essay. So you should decide the topic early. Short 4-page write-up, IEEE conference format. So special guidelines will be uploaded regarding how to write the IEEE or how to write this essay. And naturally, it would be presented afterwards to the class. I just, for the people, give an example of some of the topics which you can, and there are many others. If you Google, there are so many applications of IoT that it's a time that you can look at various fields where Internet of Things can apply itself, bring many dividends. So the topic could be like smart building, IoT in healthcare, security in IoT, privacy, recycling and the Internet of Things, unmanned vehicle, smart home, smart cities, and as I said, many more topics which you can look into. So coming to a definition of the Internet of Things. The term Internet of Things generally refers to scenarios where network connectivity and computing capability extend to objects, sensors, and everyday items. So what is meant by the everyday item? The items which are not normally considered computer. It can be, for example, even your eyeglasses that communicate with the internet, or it can be your fridge. So the things which are normally not considered computer. And this allows these devices to generate, exchange, and consume data with minimal human intervention. So it's a type of a passive interaction, not an active interaction. Normally, the interaction which we see today on the internet, once you open your laptop, open your tab, it's an active participation. But Internet of Things is in fact a passive interaction. So this is a definition, but there is, however, no general universal definition. There are different definitions that people say, but this definition does communicate and does convey what is meant by Internet of Things. So why we should study, or why you as a student should take this subject of Internet of Things. It is due to the reason that Internet of Things is an emerging topic of technical, social, and economic significance. If you are from the technical side, as I know in my class, the people come from various backgrounds. It's a master of IT. Some people come from the technical background, and we do have some people who come from the social sciences background. So this unit, Internet of Things, has to offer something to every student who comes in this course from different background. So there are technical opportunities, there are social opportunities, and economic significance. We would be talking about these things one by one. So the consumer product, durable product, cars and trucks, industrial and utility component, sensors and other everyday objects are being combined with internet connectivity and powerful data analytic capabilities that promise to transform the way we work, live, and play. So if you see, there is technical opportunity, that is the sensors, these objects which will have this internet connectivity. So it means not only the sensors, but a communication aspect of it. And naturally, data analytics, through which we can analyze the data which is gathered through the use of these sensors. And then it will transform the way we work, live, and play. That's something very interesting. So it means there are going to be great social impact of Internet of Things. In fact, the internet once came, we were not knowing that how it will impact our life. Even just one thing, these various social media websites that have changed the society in a way that was not predicted earlier. So we think Internet of Things will also change the way we work, we play, we entertain ourselves, and how we live. So there are a lot of opportunities. So as there is a lot of opportunities, it says projection for the impact of IoT on the internet and economy. It's huge. It's very impressive. Some anticipate that as many as 100 billion connected internet devices will be by 2025. So that's something quite big. And so it brings a lot of economic impact. So the estimated global economic impact is more than $11 trillion by 2025. So it appears to be a very happy forecast. Yeah, maybe. So as a student, what is your opinion? What do you think? Will it be like that? So I would talk about it. So there are significant challenges that are with the Internet of Things. If we have to realize its potential benefits, these challenges, these must be handled. So talking about, there are societal challenges. That is the privacy fear. So it means if your things which are at your home, your fridge is talking on internet, so perhaps it's also giving out your eating habits, your drinking habits. And maybe if you have a Internet of Things based dustbin, it will also be telling you that what type of waste you produce. Then is the surveillance concern. Yeah. So it means there is always a problem that the people talk about the security services, they talk about surveillance, and the human rights group, they talk about the privacy right of the individual. So that's also a challenge which Internet of Things will produce, and it would be a huge challenge. Then is the security concern. So it's a little different than the privacy. It means the data which is gathered through the Internet of Things devices, if unauthorized access to this data is made, so it can be misused. So these are the challenges, and it's necessary that the society or the people who want to use the Internet of Things devices, they should be confident that these challenges, they are handled. Their data is not going to be misused. Their data is private and they are not being spied. Then there are technical challenges. We are talking about sensors. We want to have the sensors which can measure many things. We want to have the sensors which are very small so that we can place them at every place. And then we will like that their power consumption is very less. So we want to place them at the places where they are there. We need not to change the batteries for years, maybe 20 years. We put our sensors and we don't require to change the batteries. But then it means these sensors, if they have to be cost effective, if they have to be cheap, we also do not want that they will have a lot of computing power. If they have a more computing power, for example, if you are running encryption algorithm on that, it means they would consume more power. So, and naturally, such sensors would be expensive then. We want these expensive to be cheap. We want their power consumption to be less. That brings us to a dilemma. That brings us to the dilemma of security and privacy. We want that these communication, these data, these measurements, they should be secure and private. And we also do not want to have some encryption algorithm running at the sensor side, high computing devices. No, because then the cost of those sensors will go very high. So these are conflicting requirements, and these are the technical challenges which have to be surmounted, which has to be tackled for the success of Internet of Things. Then it's the data analytics. So what we are, by a huge number of sensors everywhere, there would be a huge amount of data which would be going on, which would be gathered. And then we want a new algorithm to make sense of this data. We want to have the inferences. So we have to go for new algorithm which can give us very meaningful insight in this data. So the next thing is the communication technologies. That's also something. We have the sensors which we place at various locations, and then we want to have the data or the measurements taken by these sensors sent to the central station or maybe over the cloud. So it means you are looking for a reliable communication technologies. You are talking about something which is everywhere. Anytime you can connect to them, there is reliable. So it means no measurements are lost. So these are and then you want these communication technologies to be cheap. You do not want that to spend a lot because there would be sensor everywhere. So you want these to be very cost-effective communication technology. Then it brings to the next challenge. Because Internet of Things is an emerging field, there are various vendors who have jumped into this area because of, naturally, the economic strength or the economic feasibility and the economic benefit that the Internet of Things brings with it. So there are different companies who are working, and that's a problem. So at the moment, there are lack of standards. And if standards are not followed, it brings to the problem of interoperability of these devices. So it means a device made by company A would not work with a server of company B. And then there is a problem of development challenges. It's a new field. So naturally, you have to have a very good technical skills. You would want to have a hardware skills. And so there are the development challenges also along with these skills. Once you are developing, you do not know how the people would react to it. So these are the development challenges. And then is the challenge of enabling technology. So we are combining various things. The concept of combining computers, sensors, and network to monitor and control devices. It's an old concept. It's not a new concept. But now it's possible. It's possible because now the technologies needed to do these things are right. So you have, for example, widespread adoption of IP-based networking. We have gone from IP version 4 to IP version 6. Then you have ubiquitous connectivity. So the connectivity is everywhere. Computing economics, it means now you have the hardware which can do a lot of computation, and they are very cheap. A thing like a Raspberry Pis, Arduino boards, they are considerably powerful, and they are just $30 or so. So it means you have now the computing economics. You have the devices which are cheap and do your task. The miniaturization, we have gone with that nanotechnology, small sensors which can be placed at various places. Then it advances in data analytics. We know the big data, and with the big data, there is the development of these various algorithms which can make inferences, can give us meaningful insight into this data. And naturally, the rise of cloud computing. So we can put our data on the cloud, and at the cloud, more powerful machines can work on this data, manipulate it, and give us the required information. So these are actually technical challenges. Because we talked about Internet of Things, that it will change the society. It will change how we work, how we interact, how we play. So there are also societal changes, the legal challenges. So the legal changes is, we know there are many new regulatory and legal questions. So the students, what do you think what those legal questions can be? What is your opinion? Yeah, we see already we have a problem that internet, that data flows across the boundaries. And if the data that flow across the boundaries, which country's rule should be applied? We always see the problem in various countries that the rules which are in United States of America, they are different than what we have in the European Union and in other countries. So now with the Internet of Things, this flow would be much higher. It would be in many folds. So that those legal challenges are there. And then the data collected by Internet of Things devices is sometimes susceptible to misuse. So it would lead to some discriminatory outcomes. For example, if you have a data of physical fitness of an individual, that is on the basis of maybe the Fitbit watch, which we see everyone wearing nowadays, and that is somehow compromised, and perhaps a job opportunity is denied to an individual because of that data, not because of his competency or technical competency, but on the basis of the health. So there are legal challenges that how we would handle these types of problems. And we know the laws are reactive mostly. They are reactive to the situations. Once they happen to see some case, on the basis of that case, the legislation is made. So that brings us to a problem that Internet of Things is an emerging field, and the laws which have to be made, we do not know what laws should be made because they have to be. And naturally, the technology speed is so fast that the legalization, the making of the rules does not move that fast. So that's a challenge. And then the conflict between law enforcement, surveillance, and civil rights, the two groups which are on the opposite side, talking about and giving valid reason for both surveillance and civil rights. Then is the problem legal, or we have the legal rules at place that regarding the data retention and destruction policies. How long the data should be retained? How it should be destroyed? So these are the legal challenges that have to be looked into. So if you are from the legal side, you are taking this course, so you know there is a lot of thinking. There is a lot of thinking which is to be done by the legal fraternity. What is the legal liability for intended use? For the company that is gathering the data, for the people who used it. So that's also to be looked into. So legal framework for security breaches or privacy lapses, that has to be defined. So if we look at it with the sensors everywhere, sending the data, a huge amount of data to the central location, maybe over the cloud. So we are at the moment living in a global village. So we would be moving from a global village to a hyper-connected village. Rather, not a village. It would be a hyper-connected world. Everyone connected to each other. So it's a hyper-connection. And naturally, the hyper-connection brings its own challenges. And as we have seen up till now, societal challenges, technical challenges, legal challenges, they have to be handled. Surely, then we would see the success. We foresee economic success, the comfort that Internet of Things promises to bring. So with this, I come to the end of my presentation, and hopefully this will act as a stimulus for the students to take this course of Internet of Things. Thank you.